Hello students, welcome to maths class. So we are dealing with the problems integrating by partial fractions, right? So actually this is a 2A topic, partial fractions. By using those partial fractions we are doing the integration. Okay, so how we are doing means in partial fractions depending upon the denominator value, whether the linear factors are different or whether any linear factor is repeated or whether any irreducible factor is there. According to that situation we have to take a different type of partial fractions, right? After getting the partial fractions we have to integrate the given problem. Okay, so now come to new type of method. So come on, find the integral x plus 3 by x minus 1 into x square plus 1. Okay, so if you observe here it is a linear factor is there, and now here if you observe it is x square plus 1. If it is x square minus 1 we can reduce into linear factors x plus 1 into x minus 1, but it is x square plus 1, right, which is irreducible linear factor. So if it is irreducible factor, right, we cannot reduce into linear factors, then we have to take the partial fraction in a different form, right? First we have to find the partial fractions, then we have to integrate the problem, right? So come on, come to the question. So solution. First, what is the given question to us? Given question is integral x plus 3 by x minus 1 into x square plus 1 into dx. This is the given question to you. So first try to get your partial fractions, that is x plus 3 by x minus 1 into x square plus 1. This is a linear factor and this is irreducible linear factor, right? That means we cannot reduce into linear factor. So whenever it is like that, for the linear factor we will take one fraction. This is normal linear factor. For that we will take one fraction like this. Already I said to you how we have to take the fraction, means some constant value by that linear factor. Next, for this irreducible factor we have to take, remember this is bx plus c by x square plus 1. If it is x square minus 1, we can reduce it, isn't it? We can write x square minus 1 square, a square minus b square form, a plus b into a minus b, x plus 1 into x minus 1 we can take, right? But we cannot reduce it, it is irreducible factor. Whenever irreducible upwards we have to take bx plus c. Generally if linear factor, some constant, just one constant by that linear factor, isn't it, we will resolve. But here whenever it is irreducible, for that we have to take bx plus c, and you consider that as equation number 1. Okay, so next, come on, how we can take this one? It is x plus 3 by x minus 1 into x square plus 1 is equal to, you take the values x minus 1, we have taken the LCM, right? X square plus 1 into a into x square plus 1 plus bx plus c into, come on, x minus 1. This side will get cancels. Now you write this as x plus 3 is equal to a into x square plus 1 plus bx plus c into x minus 1. This as equation number 2. Okay, so now what I said, by using this equation we have to get all our constant values. How many constants are there? Here a, b, c. 3 constant values we have to derive from this equation. So how we will derive the constant equations? I said take one suitable x value so that one value remains and all the other will get cancels. Like that we have to select the x value. So first I will take put x is equal to 1, right? X is equal to 1 in second equation. Okay, then what happens? So here it is 1 plus 3 is equal to a into 1 square plus 1 plus b into 1 plus c, right, into 1 minus 1. Okay, so 1 plus 3 is 4 is equal to a into 1 square is 1, 1 plus 1 it is 2 plus, come on, it is b plus c into 1 minus 1, 0. So what happens? 0 into b plus c, it will be 0 only, right? So 4 is equal to 2a implies a is equal to 4 by 2 is equal to 2. You got your a value. Now you select another x value so that we can get another value. So now you put x is equal to 0 in second equation. Then what happens? This side, left side, 0 plus 3 is equal to a into 0 square plus 1 plus b into 0 plus c, right, into 0 minus 1. Okay, so this is 3, right, is equal to a into 1 is a, right, and 0 plus c, right. So it is c into minus 1. So implies it is 3 is equal to a minus c, implies c is equal to a minus 3. Okay, so sending 3 that side, bringing that minus c this side. We want a c value, right? That is negative. So bring this side, it is c. So what is your a value? A value is 2. So it is 2 minus 3 is equal to minus 1. C value we got minus 1. So now we got a value, c value. We have to get b value now. So how we will get our b value? Means there is no chance of substituting x value here. In such cases we have to equate the coefficients of like terms on both sides in equation 2. So from 2, right, from equation 2 we will have x plus 3, right, is equal to, come on, it is a x square plus a plus b x square minus bx plus cx minus c. Okay, so is equal to, you take x square common, then you will have a plus b. Next x term common, you will have c minus b. Last constant a minus c is equal to, here x square term is there, this side we don't have x square term, so we can write that as 0 into x square. Can we write? So that I will equate the coefficients of like terms on both sides. Okay, so no x square term, so 0 into x square, right. Next plus 1 into x plus 3. Okay, so is equal to this equation. So equating x square coefficients, isn't it? Equating x square coefficients on both sides, right, on both sides. You give this as a third equation in 3, right. We equated the coefficients of x square on both sides. Coefficient of x square is 0 and coefficient of x square is a plus b, right. We want b value, no, so send a this side. So b is equal to minus a, so is equal to minus of, what is the a value? 2, a is equal to minus 2. Okay, so you got b is equal to minus a, that is equal to minus 2. So, b is equal to minus 2 value. We got all the values. We got a value, right, next c value, next b value. Okay, so now you write your first equation. So, therefore, from 1, right, from first equation, what is your x plus 3 by x minus 1 into x square plus 1 is equal to a by x minus 1. A is 2, right? So, 2 by x minus 1. Next, plus bx. b is minus 2, no? So, minus 2x plus c. c value is, we got c is equal to minus 1, right? bx plus c means minus 2x minus 1 by x square plus 1. x square plus 1. Now, you take integral for this. So, till this it is partial fractions only. We resolved the given fraction into partial fractions. So, actually in the beginning, while doing this type of problems, all the linear factors are different, right? So, for each linear factor we have to take one fraction, right? That is first one. And second one, in second case, one linear factor is repeated, right? So, there that method is different, right? First time we have to take constant by that linear factor, next constant by that linear factor whole square we have taken. Okay, so now in this problem, one value is given as irreducible factor. One factor is irreducible. That means it cannot be reducible into linear factors. It cannot be reducible into linear factors. Okay, so whenever irreducible factor is there, we have to take the fraction as like this, bx plus c by, generally only constant, a by linear factor, b by another linear factor, c by another linear factor, like that we will take. But whenever it is irreducible factor is there upwards, we have to take bx plus c form. Okay, so then try to get a, b, c values. Once you got a, b, c, you substitute in that equation. This is called resolving the fraction into partial fractions. So, by using partial fractions methods only we resolved. Now, we have to integrate by our normal method. So, therefore, integral it is x plus 3 by x minus 1 into x square plus 1 is equal to, into dx will be there in all the integrals, into dx will be there, right, is equal to, it is 2 by x minus 1 plus minus 2x minus 1 by x square plus 1 into dx. Right. So, we can write this as, whenever plus minus we have to take separate integrals. So, it is integral 2 by x minus 1 into dx plus integral minus 2x minus 1 by x square plus 1 into dx. 2 is a constant. Whenever in a integral some constant is there, you can write that constant outside. So, is equal to 2 into 1 by x minus 1 dx. Okay. Next, we can write separately this one also, this by this by this. Okay. So, how we can write? We can take minus sign outside by 2x by x square plus 1 into dx. Similarly, minus outside 1 by x square plus 1 into dx. Okay. So, come on, now we have to take here t is equal to x square plus 1. Okay. So, dt by dx is equal to 2x, and send dx that side, dt is equal to 2x dx. Okay. So, is equal to, it is 2 into integral 1 by x minus 1 is log of x minus 1, log of x minus 1, okay, minus integral dt by t, okay. Next, minus tan inverse x. It is standard form. Actually, after resolving the integral value, that means given question into partial fractions and applying the integral, it will comes into some standard formula form. See, it is a standard formula. Integral 1 by x square plus 1 is tan inverse x, and integral 1 by x minus 1 is log of x minus 1. Okay, so it is tan inverse x. Okay, and this is nothing but integral dt by t is log t. Okay, so is equal to, it is 2 log of x minus 1, right, minus log t. Okay, so minus tan inverse x plus c. So in t place you substitute your original value, right. What is that? Minus log of t. T we have taken as x square plus 1 minus tan inverse x plus c. That is the answer of your question. Okay, so come on, how we solved this one means, first of all you should know how to resolve the equation into partial fractions. Okay, so in the integral problem, suppose fraction is there and downwards in denominator some linear factors, irreducible factors are there. We have to go for partial fractions. They don't mention, just they will ask like this, find or evaluate or calculate. All are same, right? Evaluate integral of this value, like that they will ask. Okay, so whenever it is like that downwards in denominator we are having linear factor and irreducible factor. For each linear factor we have to take one fraction like constant by that linear factor. For each irreducible, right, for each irreducible factor we have to take that as bx plus c. Okay, generally linear factor means some constant by that linear factor, but whenever it is irreducible, right, then we have to go for bx plus c by x square plus 1. Okay, so now you take the LCM, right, x minus 1, x square plus 1, x minus 1, x square plus 1, both will get cancelled. You will get one equation in terms of A, B, C. Now by using this equation we have to get our A, B, C. How we will get our A, B, C? We have to select some suitable x value so that the remaining two values will get cancelled and we will get one constant value. Like that we have to select our x value. Just by observing this, with the practice, with observation, you will know which value should be taken as x here. Okay, so here if x is equal to 1, what happens? If we substitute x is equal to 1 in this equation, this will be 0, right? 0 into something 0 and you will get your a value. See, a is equal to 2. Next we have taken x is equal to 0, right? Then we have taken, we got the c value, c is equal to minus 1. After that there is no chance of substituting the x values, right? In such cases, and we want one more value also, one more constant value, that is b. So how we can find that b means, in such cases just you equate the coefficients of like terms on both sides of this equation 2. Okay, so how we will equate? Just first expand this and try to write in the order x square term, x term, constant term. This side also try to write in the same form, x square. There is no x square term means just we will write 0 into x square, right? Here we are having x square term, x term and constant term. We have to compare the coefficients of like terms on both sides means we need x square this side also, but it is not there. Then how we will write? It is 0 into x square. Okay, so you take 0 into x square, 1 into x plus 3 is equal to this one. Now equating x square coefficient on both sides. Okay, you equate them. So your x square coefficient is a plus b. Here your x square coefficient is 0. Right. Actually we want only one value, b value. That's why I have taken only, we equated only one coefficient, x square coefficient on both sides. Right. So then a plus b is equal to 0. We want a b value. So send a that side, b is equal to minus a. Already we got a value as a 2. So b is equal to minus 2. Once we got all the constants ABCs, you substitute in your first equation. Right. So we substituted. After that you take your integral. So from here, from this step to this step, this problem belongs to partial fractions. We are resolving the fraction into partial fractions. Okay, so only partial fractions we got it. After that we have taken the integral for that, integral of this one. Okay. So integral of this one means plus sign is there, minus sign is there, right. So whenever plus minus is there in between the two terms, right, we have to take separate integrals, right. Take the separate integrals, and again from this also we can take a separate integrals. It is of the form a plus b by c form, a by c plus b by c form we can write. That's why minus 2x by x square plus 1 minus 1 by x square plus 1 we have taken. So plus of minus, minus, isn't it? So minus is taken outside, and if you observe, this is substitution problem, isn't it? So if we differentiate this one, we will get this one. In such cases we will go for substitution. T is equal to x square plus 1. So dt by dx is 2x, dt is equal to 2x dx. So in 2x dx place you take a dt by t, right, and integral 1 by x square plus 1 is tan inverse x. Okay, so it is 2 log of x minus 1 minus log t, right. So where t is x square plus 1, we have taken t is equal to x square plus 1, substitute it, minus tan inverse x plus c. So after the completion of all the integration, we have to write plus c, as well as we have to substitute t value also. Question is in terms of x, so answer also should be in terms of x only. Okay, so be clear with the concept. Okay, so whenever it is like that, we will write this as a by c plus b by c we will write, isn't it? So this is our problem. Okay, so observe carefully. So integral x plus 1 by x minus 1, x square plus 1, irreducible factor. Only one thing you have to remember here, downwards we are having linear factor, irreducible factor. We have to solve the problem by using partial fractions. They won't mention. You should recognize, by seeing the problem you should get the idea. We have to solve this problem by using partial fractions, and given one factor is irreducible, it cannot be reducible into linear factors. Whenever it is like that, in its place we have to take bx plus c by x square plus 1. Okay, so then you take the LCM, cancel them. Okay, so then you will get your equation 2. Okay, so you will get your equation 2. In that equation 2, right, in x place we have to take some suitable value so that we will get all our constants, ABC values. Once we got ABC values, substitute in equation 1, then take the integral. After substitution, your question will be in some standard integral formulae form, and we can easily find the integrals. Okay, so be clear with the concept. That's all for today. Have a nice day.